Forensics Lecture 6-2, Drug Control Laws and Forensic Drug Analysis. Drug control laws. The Controlled Substance Act illustrates how legal drug classification system, which was created to prevent and control drug abuse. Federal law establishes 5 schedules of classification for controlled or dangerous substances on a basis of 3 things: the drug's potential for abuse, the potential for both physical and psychological dependencies, and its medical value. At any time, the U.S. General has the authority to add, delete, or reschedule a drug as more information becomes available for that drug. A schedule of classification starts with Schedule 1 drugs. These drugs have a high potential for abuse and have no current acceptable medical use. So heroin, marijuana, LSD, and those type of drugs. Schedule 2 drugs have a high potential for abuse, but have a medical use with a ton of restrictions. Cocaine, PCP, most amphetamines, barbiturates, which are prescription drugs and narcotics, all fall under Schedule 2. Schedule 3 drugs have less potential for abuse, but have a current acceptable medical use. So codeine, anabolic steroids fall under Schedule 3. Schedule 4 have a lower potential for abuse and have a current medical use as well. Darone or phenobarbs fall under Schedule 4. And Schedule 5, which is the last schedule of classification, must show low abuse potential and have medical uses. So opiate drug mixtures that contain non-narcotic medical ingredients fall under Schedule 5. The criminal penalties under the Act are directly related to the schedule that they fall under. The most severe penalties are associated with drugs listed in Schedule 1 and 2, which is up to 20 years in prison or a fine of up to $1 million for an individual, or up to $5 million for multiple people involved in the sales. When we talk about forensic drug analysis, the challenge or the difficulty is identifying the drug and by selecting a process or procedure to ensure that it is specifically identified. There can be no room for error when you're identifying a drug because it is going to directly lead to the punishment of the individual. So screening and confirmation play a role. Forensic chemists need to develop a plan of action that's going to yield the drug's identity. And it's divided into 2 phases: screening tests, which is a non-specific preliminary test, and this is to reduce the possibilities of types of drugs, and then confirmation tests, which is a single test that specifically identifies the substance. In the screening test, it subjects the material to a series of color tests, which will produce characteristic colors for more of the commonly encountered illicit drugs. And then the second phase is devoted to pinpointing and confirming that identity. So in confirmation, the forensic chemist employs specific tests to identify a substance to exclude all other known substances. Individually, though, each test isn't enough. There needs to be a combination of tests that can result in characterizing one and only one substance. Which brings us to qualitative versus quantitative analysis. When we talked about the qualitative analysis, it relates just to the identity of the material, the screening process. It reveals that there is a presence of drug. In the quantitative, it requires the determination of the percent composition of the component of the mixture. So it concludes the amount of each chemical in the substance that was obtained. screening test is the color test, and many drugs yield characteristic colors when brought into contact with specific chemicals. There are 5 primary color tests that are used. One is for heroin, morphine, and most opium derivative drugs. Marquise, it turns purple in the presence of these drugs. Another one is for barbiturates, Delicompagnie, which turns violet blue in the presence of them. Duquesne Levine, which turned purple when chloroform is added in the presence of marijuana. And then Van Uyck, which turns purpley blue in the presence of LSD. And the last one is the Scott test, which turns blue in the presence of cocaine. Another screening test that they have is called the microcrystalline test. It's a little bit more specific than the color test. When chemicals are added to a drug, a crystalline structure forms. And when they view this under a microscope, the size and the shape are highly characteristic of each drug. It's very quick, doesn't require the drug to be isolated from any components that it may be mixed with. Scientists don't fully understand why the color test and the crystal test produce these characteristics, these results, but from a forensic point of view, that part's not important. The important part is that they do, and it can help them identify the substance. Another test used to analyze drugs is chromatography, and this is a way of separating and tentatively identifying components of a mixture. The theory of chromatology is based on the observation that chemical substances tend to partially escape when dissolved in liquid or dissolved in a solid substance. And so what this gives forensic chemists is a process called thin layer chromatography. It uses a solitary stationary phase coated onto a glass plate and the mobile liquid phase to separate the components. And so what happens is the liquid rises up the plate by capillary action, so like as if it was moving up within the blood vessels, and the sample distributes as patterns, and it's shown as bands or dark spots. And then this unknown substance is then used to compare to standard samples to help identify that unknown sample. So if they're comparing the sample bands to the known cocaine band and they match up, that can indicate that unknown substance contains cocaine. And then another one that they use is gas chromatography, and this causes the moving phase, which in this case is called carrier gas, and it flows through a column. After the mixture has moved the length of the column, it separates into its components. The time required for the components to separate is called retention time, and this is then again used to compare it to known substances and identify materials. Again, though, none of these are acceptable alone. They have to be used in conjunction with other tests as well. This concludes 6-2 lecture. There's a quiz next class.